because we have only one lightning talk for this session. So I'm going to pull that up ahead in the schedule to right now. And after the lightning talk, we will have the group discussion. So what we're going to do is, Ekaterina, where are you? There you are. Very good. What I'm going to do is I'm going to do a screen share on my end and show you a slide, and then you can quickly tell us your lightning talk. There we go. It should be visible.
Awesome. Yeah. Hope you can hear me. Hi. My name is Ekaterina Ilin. I'm a PhD student at the Leibniz Institute for Astrophysics in Potsdam, and I bring you a little science nugget to finish off this day. I think this is not yet tweetable stuff, so please don't tweet about it yet. Last year I've been talking about super flares. I'm still obsessing about super flares, but now it's even more giant flares, and the stars have gotten even smaller. And my question today is, where on the stellar surface do these giant flares occur? And turns out I can determine the location of that flaring region from looking at the light curves of super flares. Test has been a gift, obviously. So I want you to look at the figure. There you see the test light curve of an M7 dwarf in black dots. That M7 dwarf is a super fast rotator. It has a period of 4.6 hours, but that rotation period I removed from that signal. So what you see is the residual. And that looks kind of suspicious. And we build a model around this to show what it actually tells us. So now please look at the gray lines. We build a model that predicts that these gray lines represent the event, so the flare, that actually happened on the star. So a pretty big one. Now look at the red line that you might have trouble seeing because it overlaps so well with the black dots. This is what this flare, according to our model, is supposed to look like to the observer. So it starts behind the limb. That's why we don't see the peak. And then it comes into view and rotates in and out of view a couple of times. So the cool thing is our model not only tells us what the flare looks like, but if we can determine the inclination of a star, which we could because we got a high-res spectrum, we can tell the latitude of that flare. And in this case, the inclination was 87 degrees, so pretty much edge on. And the flare latitude turns out to be about 82 degrees plus minus a handful. Better still, we have not detected only this one, but 3 such events in late M-Dwarfs tests, and we actually went back to Kepler and found the L dwarf that was monitored by the original mission and found a multi-period flare there too. So I'm excited to see what the next test cycles will bring in and how we can find out more about locations of flares on them.
Yes, thank you, Ekaterina. So these are all the presentations for our second session today. And